Welcome back, guys. हम करेंगे radioactivity. Question 14, paper 25054. Let's start. Question 14. In an experiment to collect a small quantity of helium, a sample of radon 222 is enclosed in an inner glass tube which has a very thin wall. Figure 10.1 shows that this tube is placed inside a container that is initially evacuated. So this is a vacuum. This is the seal to ensure nothing goes out. This is the radon 222 or yeah, inner glass tube in which the radon 222 is present. Both the container and the inner glass tube are sealed. As the radon 222 decays, alpha particles through the thin wall of the inner glass tube. Alpha particles pass from the inner glass tube because it is very thin. Figure 10.2 shows how the total number of alpha particles produced by the radioactive decay of the radon 222 changes as the time passes. So yeah, it is showing us the number of particles that is being decayed, that are decayed of the, yeah. So using figure 10.2 determine the number of alpha particles produced in 7.2 days. तो 7.2 days यहाँ तकरीबन होगा ये 7 6.2 6.4 6.6 6.8 7 7.2. So yeah, this is the valid answer, which is gonna give us an answer of 2.1. 2.1 into 10 raised to the power of 10. 2.1 2.1 into 10 raised to the power of 10. तो आगे देख लेते हैं. Initially, there are 2.8 into 10 raised to the power of 10 particles, atoms of radon 222 in the inner glass tube. As the radon 222 atom decays, it produces an alpha particle. Calculate the number of radon 222 atoms that remain after 7.6 days. So first of all, we have the total number of particles. The total number of particles है 2.8 into 10 raised to the power of 10, and the particles that have decayed is determine the particles produced in 7.6 days is 2.1 into 10 raised to the power of 10. That will give us an answer of, अगर हम इसको 2.8 को माइनस करें 2.1 से, we will get 0.7 into 10 raised to the power of 10, or we can say 7 into 10 raised to the power of 9. पीछे देख लेते हैं. ये 7 into 10 raised to the power of 9. ठीक है ना? तो yeah, this is the answer. Easy as that. You just have to subtract the number of whatever the radon particles that have decayed minus the number of total atoms in that. Using the number of radon 222 or atoms present initially and the number present after 7.6 days, calculate the half-life of the radon 222. So initially हमारे पास कितने particles थे? The total number of particles we had initially was 2.8 into 10 raised to the power of 10. So what is 2.8 into 10 raised to the power of 10 का half? That is 1.4 into 10 raised to the power of 10. तो पहले हम देख लेते हैं 1.4 into 10 raised to the power of 10 कहाँ आता है. It is going to be 1 2 3 4. Here comes 1.4 into 10 raised to the power of 10, and इसकी जो corresponding value होगी ना with the time, that will give us the value of the half life. So this is gonna be 3.8 into 10 raised to the 3.8 days, sorry. 3.8 days will be the value of half life. So it's very simple, it's nothing hard. तो ये देख लेते हैं 7.6. इसको क्यों डिवाइड किया? I don't get it. The two half lives. If we have the initial value of the atoms of radon, which is 2.8 into 10 raised to the power of 10, we don't have to do none of that. We can just divide this by 2. What the value we will get, हम उसके साथ corresponding उसका time वाली value ले लेंगे, और जो time की value होगी, that will be the time in which half of the unstable nuclei decay. ठीक है ना? As simple as that. आगे देख लेते हैं. Using the number of radon 222 atoms present initially and the number of अच्छा ये तो हमने कर लिया. The alpha particles become helium atoms which are collected in vacuum, shown in figure 10.1. Explain in terms of properties of alpha particles why the walls of the inner glass tube must be extremely thin. Because, as we know, alpha particles जो होते हैं वो सिर्फ मतलब 6 to 7 सेंटीमीटर ट्रैवल कर सकते हैं. 6 to 5 to 6 सेंटीमीटर ट्रैवल कर सकते हैं इन एयर. और बाकी अगर वो 5 to 6 सेंटीमीटर से आगे जाने की कोशिश करें दे गेट एब्जॉर्ब बाय द एयर. ठीक है ना. सो द glass tube must be extremely thin for the alpha particles to pass. ठीक है ना. Because अच्छा अब इसका आंसर फॉर्मल आंसर बता देता हूँ मैं इसका. Because the penetrating power of the alpha particles is extremely low, therefore the glass tube must be extremely thin. Alpha particles very weak penetrate. अब आगे देखते हैं हम. In some parts of the world, radon-222 accumulates in the air in buildings and is breathed in by people. Explain why the presence of alpha emitter in the lungs is particularly hazardous. Because जो alpha particles होता है, although it has a very weak penetrating power, it has a very high ionizing power. ठीक है ना. It has the highest ionizing power between the gamma beta. ठीक है ना. और जो इसकी गैप आयनाइजिंग पावर होती है दैट कैन कॉज कैंसर एंड दैट कैन कॉज म्यूटेशन एज वेल. सो या strongly ionizing ionization causes cell mutation cancer. So yeah, so that is gonna be it for this video. I hope you enjoyed. Have a great day. Allah Hafiz.